First, find out for magnesium bicarbonate hardness, how much you got answer?
10, ma'am. 10.
10, okay. For calcium bicarbonate?
10, ma'am.
What is the molecular weight?
162.
162. Okay, 16.2 by 162 into 100.
Yes,
Okay,
ma'am.
what is
10.
the answer?
10, ma'am.
Okay, now third one, calcium chloride?
100 ppm.
100 ppm. Okay, calcium sulfate?
1 ppm.
1 ppm. Okay, ma'am. So now they asked us to find out here to calculate temporary, permanent, and total hardness of water in ppm, in degree Clark, in degree French. Okay, so you got the answer in ppm already. Okay, milligram per liter, that is equal to ppm. So you can write directly. Okay, so you can write directly ppm. Now you can convert into degree French and degree Clark. So convert the students. Everybody first find out here temporary hardness. What is the temporary hardness, ma?
20 ppm.
20 ppm. Okay. So permanent hardness, how much you got answer?
101 ppm.
101 ppm. Next, total hardness combined together?
121.
121. Okay. So now you convert into degree Clark first. 20 into?
Ma'am, temporary hardness in degree French is 2 degree French.
Okay.
And in degree Clark it's 1.4.
1.4.
Degree Clark.
Temporary hardness is 2 degree 1.4 degree Clark temporary hardness.
And
Permanent hardness?
Permanent hardness 7.07 degree Clark and
Okay,
10.1 degree French.
Okay, ma. Next, total hardness also you complete it. Students, total hardness also in degree French and degree Clark. What you got, ma? Total hardness in degree French, degree Clark? 121 into
12.1 degree French.
Okay. Next, degree Clark?
8.47.
8.47. Okay, ma. So everybody, you take this problem, complete it. Those who have not completed, okay, this is compulsory problem. In question bank, it is given. For mid exam, you will get this problem. Okay. Those who have not able to do, you can complete now. Any students are there like that? On your video, ma. B7, B1. On your video. Now B8 is there. B8. Where is B8? Where is B8, ma?
Yes, ma'am.
B8, show me your notes, ma.
Ma'am, I'm having camera problem. Back cam.
Camera problem. No, you have written the problem now. Okay. Okay. Next, Sai Kumar. Sai Kumar. Where is Sai Kumar?
Present, ma'am.
Sai Kumar, on your video. You have done the problem?
Yes, ma'am.
On your video, ma, Sai Kumar. Naveen Kumar, 77. Naveen Kumar. B. Raju. Who is this B. Raju? 94, 96, 97. Okay, students, we'll do next problem also. We'll continue. Okay, na? So copy this problem. 4 problems are there from hardness. Okay, 3 problems from Edta method. So everybody, this problem you take, ma, calculate temporary and permanent hardness of water sample. Copy this, everybody. Copy this problem. Last problem in hardness. CRs, tell the students to join. Some of them left. Nikila Sri is there. Narsimha Reddy. Send one message to everybody. They have to join. Attendance is compulsory. Okay. So copy this problem. We'll complete this also. Calculate temporary and permanent hardness of water sample, which contains 6.8 milligram of calcium sulfate, 33 milligram of calcium chloride, 40 milligram of magnesium chloride, 24 milligram of magnesium sulfate per liter of the water sample. So everybody use the formula of hardness. Calculate the hardness ma for each salt given for you amount. Students, you are doing problem? Hello?
Yes, ma'am.
Okay, ma. You know the formula. Everybody find out the hardness and tell me the answer.
Ma'am, could you repeat the values?
Calcium sulfate, 6.8 milligrams, calcium sulfate, calcium chloride, 33 milligrams, magnesium chloride, 40 milligrams, magnesium sulfate, 24 milligrams. Ma. So here you have to find out, you have to calculate temporary and permanent hardness of water. Temporary and permanent hardness of water. How much you got, ma, for calcium sulfate? 6.8 by students, molecular weight of calcium sulfate. Molecular weight of calcium sulfate. No one is telling me. We learned molecular weight for 6 salts, ma.
136, ma'am.
136,
So
ma'am.
6.8 by 136 into 100. How much you got?
5 ppm.
5, huh? Okay. Now next one you do calcium chloride.
Ma'am, one doubt, ma'am.
Hmm.
In the screen sharing, you are giving that question. That is a wrong question, right? Means the previous question, right?
Which one, ma?
In screen sharing, you are giving the previous question, ma'am. So I have no idea about the values or whatever salts are given, ma'am, in the question.
This one, huh? Present. What I am giving this question you are asking me. This
Yes, ma'am.
problem.
Yes, ma'am.
This problem is correct only, no?
No, ma'am. My means in screen sharing, you are giving previous question, ma'am.
Previous question only, ma'am.
Previous question, huh?
The question has been not changed.
That's why
Changed,
You
ma?
did not scroll the question, ma'am.
No, ma'am.
One second,
Why?
share the screen, ma'am.
But I can see, no? Students, I can see the question, na?
మ్యామ్ మీరు ఇంకా థర్డ్ క్వశ్చన్ కనిపిస్తుంది మ్యామ్ థర్డ్ క్వశ్చన్ కనిపిస్తుంది
But I can see, ma, fourth question, na? You are
Ma'am,
not able to see.
Calcium
Sorry, cut చేసి మళ్ళీ screenshot చేయండి.
1.36, ma'am.
You want me to share again, na?
ఎస్
Yes,
మ్యామ్
ma'am. Cut it and again share again, ma'am.
Okay, okay, okay.
వచ్చింది, ma'am.
ఇప్పుడు వచ్చింది మ్యామ్
Yes, ma'am. It came.
ఎస్ మ్యామ్ ఇట్ కేమ్ మ్యామ్
Ippudu, okay, now it is visible for you?
ఎస్ మ్యామ్
Yes, ma'am.
Okay.
కాల్షియం సల్ఫేట్
Ah. This problem repeated for 4 times. This problem, what you are doing now. For calcium chloride, how much you got, ma? 33 by
33 by 111 into 100, ma'am.
33 by 111 into 100. How much you got answer?
Ma'am, 29.7, ma'am.
29.7. Okay.
Yes, ma'am.
Now, third one, ma, 40 by magnesium chloride molecular weight. Tell me, students, magnesium chloride molecular weight.
95, ma'am.
95. So 40 by 95 into 100.
$42.1, ma'am.
Okay. Now last one, ma, magnesium sulfate molecular weight. You forgot molecular weights. ma?
120, ma'am.
120.
120, ma'am.
Okay. 24 by 120 into 100. 24 by 120 into 100. See the students
20, ma'am.
question, you know now. Question, calculate temporary and permanent hardness. Now tell me temporary hardness.
0.
0. Okay, very good. Some of them, they won't write temporary hardness is 0. Okay, in the answer, you have to write compulsory temporary hardness is equal to 0 ppm. You have to write compulsory it is, because in the problem they have asked you to calculate temporary hardness. Now calculate permanent hardness, ma. All together. Calcium sulfate, calcium chloride, magnesium chloride, magnesium sulfate. Answer.
96.82 ppm.
96.82 ppm. Now everyone can check the answer, ma. Permanent hardness 96.82 milligrams. And the temporary hardness is 0. Okay. Now these are 4 problems we are having in question bank. Okay, I will send you question bank also. You can check in that question bank. 4 problems I have given on hardness and 3 problems on EDTA. So remaining 3 problems will be reasoning questions will be there. So part C, we are having 10 questions. Out of 10 questions, I have given you 4 problems on hardness. Okay, so that we completed. So you can check in PPT. I will send you today. Okay, these 4 problems. Those who have not completed in the notes, all 4 problems, you can copy again. Students understood?
Yes, ma'am.
Everybody, you have to take these 4 problems in your notes. Okay, students, now we completed problems also. Okay, your hardness problems. So next topic is, this is experiment. Okay, so we will find out total hardness, permanent hardness and temporary hardness by taking the chemicals. Okay, we use the chemicals. We will do the experiment. We'll take a sample of water and we'll find out total hardness. Okay, So write down everybody the topic estimation of hardness of water by EDTA method. Write down. Everybody write down in your notes. Estimation of, this is very important topic, students. Those are missing, okay, for them it will be difficult, I am telling you, to write in the exam. Estimation of hardness of water by EDTA method. Everybody write down topic. Estimation of hardness of water by EDTA method. Now you can see ma PPT. Students, can you see the PPT?
Yes, ma'am. Yes, ma'am.
Everybody write the topic. This is very important topic. Now write down. So what we are going to discuss in this topic means estimation of hardness of water by EDTA method. So principle, procedure and calculations. Roll number 70, you are getting sleep. Drink some water.
No, ma'am.
Breakfast చేశారు అందరూ?
చేయలే ma'am.
Write down principle, procedure and calculations. Okay. So this is experiment. We'll find out by doing this experiment total hardness, permanent hardness and temporary hardness. Students, tell me what are the temporary salts?
Ma'am, calcium bicarbonate and magnesium bicarbonate, ma'am.
Calcium bicarbonate,
Magnesium bicarbonate.
What are the permanent salts?
Calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate.
Magnesium sulfate. Okay. So we'll find out total hardness. Total hardness means both we will find out temporary hardness and permanent hardness. Okay, by this method, following this method, that is EDTA method. So what is mean by EDTA? So okay, what is mean by EDTA means ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid. So we will take the chemicals. We will use the chemicals in this experiment. That is EDTA, ethylene diamine tetraacetic acid, areochrome black tea. We will use the indicator. Okay, areochrome black tea indicator. And we will use the buffer solution, ammonium chloride and ammonia. Both we will mix here. And we will prepare the solution, buffer solution, to maintain the pH 9 to 10. To maintain the pH 9 to 10. Because we will get the here the EDTA. It can react with the dissolved salts present in water, either calcium or magnesium salts present in water. The EDTA, that chemical, the EDTA, it will react with the calcium and magnesium salts at pH 9 to 10. Students, at pH 9 to 10 under basic conditions only, the EDTA, it will react with the calcium and magnesium salts present in water. So we have to use the buffer solution. Okay, compulsory. So that we will take here. Then standard water, calcium carbonate solution we'll prepare, and water sample will take tap water. Okay, for example, you are in the college, you are doing experiment. So we'll take IRE tap water, or you can collect water from your house also. Okay, we will use as a water sample. Okay, water sample we use, and boiled water. Okay, boiled water. Okay, so we are taking 3 chemicals here. I think you are following me. 3 chemicals: EDTA, ethylene diamine tetraacetic acid, EBT, areochrome black tea indicator, and buffer solution we are taking ammonium chloride and ammonia. Both we are taking, and we are preparing the buffer solution to maintain the pH 9 to 10. And here what we are taking solutions. Solutions are, you are taking standard water. You have to prepare the standard water. First we have to prepare the standard water. Okay, that is calcium carbonate solution. So next we have to take the sample, water sample, and we have to take the boiled water. Okay, so these are the chemicals we are using, and samples we are taking standard water, water sample and boiled water. So what are the apparatus we are using here in this experiment is conical flask 250 ml, burette 50 ml, pipette 20 ml, beakers 250 ml. Okay, we will take 2 to 3 beakers here. So conical flask, burette, pipette, beakers. So these are the apparatus we are using for this method. Estimation of hardness of water by EDTA method. Students, tell me what are the chemicals we are using?
Ma'am, slide
Slides change అవ్వట్లేదు.
Change the slide, ma'am.
మ్యామ్ హెడ్డింగ్ స్లైడే ఉంది మ్యామ్ ఇంకా
Wait.
ఇప్పుడు చేంజ్ అయింది మ్యామ్. ఎస్ మ్యామ్.
Some problem is there. I will see ma today. Now tell me what are the chemicals we are using ma in this experiment?
EDTA,
EDTA, EVT,
EBT,
4Cl,
EBT?
NH4OH.
EBT?
NH4Cl, NH4OH, buffer solution,
Buffer
standard
solution
water,
we are taking.
Water sample, boiled water.
water sample,
Standard
boiled
water
water,
we are using. Water sample we are using. Boiled water.
boiled water,
Okay. What are the apparatus we are using?
conical flask,
Okay.
burette, pipette, beakers,
Pipette and beakers.
burette.
So this needed for us to do this experiment and to find out total hardness, temporary hardness and permanent hardness. Okay. So here it is also known as, students, you can see here, it is also known as complexometric method. It is also known as complexometric method. Why it is known as complexometric method means when we are doing this experiment, when we are using EDTA, okay, when we are using EDTA and reacting with calcium and magnesium salts present in water, see here in principle we can study EDTA, it reacts with water and forming a calcium EDTA complex. Calcium EDTA complex. I will show you the principle. Okay. You can see calcium EDTA complex. So in principle, what we are going to discuss is we are going to take here a sample of water in conical flask, sample of water in conical flask, and we will add first EBT indicator. That is blue color indicator. EBT indicator is blue colored indicator. So we will add 3 drops of EBT indicator in sample of water. So then we will add to maintain the pH, we are using buffer solution. So we will add only 2 drops. 2 drops we will add in the sample of water. Somebody is raised your hand. Tell me who is that? Why it is known as complexometric method? I am going to tell one now. Okay, na? Somebody, anybody is having any doubt? Just started principle now. Students, you are listening to me?
Yes, ma'am.
Yes, ma'am.
Yes ma'am.
Listen carefully. If
Yes,
you understand this, you can write by your own. Okay. So here we are taking a sample of water containing calcium or magnesium salt in water, and we are adding EBT indicator, areochrome black tea indicator, which is blue colored indicator, blue colored. Okay. And here we are adding buffer solution 2 drops. 2 to 3 drops you can add, or up to 1 ml we can add more buffer solution. After adding, immediately you can observe the color of the water. What you can observe here? Wine red color. Wine red color. So if calcium and magnesium salt present in water, immediately you will get wine red color. What is the EBT color? What is the EBT color?
Wine red color.
Blue color. EBT color is blue color, ma. EBT color is blue color. Areochrome black tea indicator color is blue color, but you are getting wine red color. Why you are getting wine red color? Because in that water sample, hard salt is present. Dissolved salts, either calcium or magnesium salt is present in water. So immediately the water color changed from here it is changed to the wine red color. Okay, you can see here calcium EBT or magnesium EBT complex is formed. Calcium EBT or magnesium EBT complex is formed, which is wine red colored complex, which is an unstable complex. Okay, so immediately what we do, we will titrate with the EDTA solution. So that EDTA solution we are taking in the burette. We will take in the burette EDTA solution. Okay, and we will do the titration here. We will add drop by drop, okay, EDTA into the sample of water. Okay, that wine red colored complex water, we will add drop by drop, and at one drop of the EDTA, the color changes from wine red color to blue color. At 1 drop of EDTA, the color changes from wine red to blue color. What is mean by that? Here completely the EDTA that is reacted with all the calcium and magnesium ions present in water and converts into a, means forming a equivalent bond with the calcium and magnesium. After all, after complete reaction of EDTA with the calcium and magnesium salts, immediately when you are adding a next drop of EDTA, so you will get the color changing from wine red to blue color. Okay, so EDTA it is forming a complex with either calcium or magnesium, that is colorless stable complex. Colorless stable complex, but it appears blue color. Why? Because of the what indicator we are using is EBT indicator. So immediately the color changes to wine red color to blue color. Okay, ma. So this is the principle of EDTA method, estimation of hardness of water by EDTA method. Okay, students, you are listening to me?
Yes, ma'am.
Okay, now listen carefully. You see everybody here. EDTA, ethylene diamine tetraacetic acid. It is a hexadentate ligand. It is a hexadentate ligand. Okay. Here, what is ligand means? It have the lone pair of electrons. It will share the electrons. It will give the electrons to the metal ions. It will give the electrons to the metal ions, and it will form a covalent bond with either calcium or magnesium, and forming a calcium EDTA complex or magnesium EDTA complex. So it is known as complexometric method. It is known as complexometric method. So here EDTA, it is having 6 lone pair of electrons. It will share that electrons to the metal ions and forming a covalent bond with the metal ions. And you can see the complex formation, metal ion EDTA complex. So when you are doing titration, when you are doing experiment, you don't know what is the reaction taking place. But here, by looking at this complex, you can understand very easily that when you are doing titration with EDTA, what is the sample of water you are taking containing a dissolved salts, calcium and magnesium, that is reacting with the EDTA, and EDTA is sharing its electrons to the metal ions and forming a either calcium or magnesium EDTA complex. So it is known as complexometric method. So in this, you can understand very clearly. We are taking hard water, EBT indicator, and buffer solution. It turns to wine red color. When you are doing titration with the EDTA, it turns to blue color. Means after complete reacting of EDTA with calcium and magnesium salts present in water and forming a complex compound. So students, everybody understood my principle? Students?
Yes, ma'am. Yes, ma'am.
What we have taken first in conical flask? Just principle only. So we didn't discuss. First, we have to discuss the procedure also. We'll discuss afterwards. First, tell me what is the principle, what we are taking here. Students?
Yes, ma'am.
Where is the calcium and magnesium present?
Water.
Where is the calcium and magnesium salts present? What you are taking in conical flask?
Water, ma'am.
What you are taking in conical flask?
Tap water.
Tap water. Okay. So tap water is containing
salts.
salts.
Calcium or magnesium salts.
What you are adding in the tap water?
EBT, ma'am.
EBT. What is EBT here?
Indicator.
Indicator. EBT is indicator. Okay. Which color it is?
Color.
Blue color, ma'am.
It is
Blue.
Blue color.
Blue.
what you are adding in tap water?
Salts.
You are adding what, ma? Buffer. You are adding what you are adding?
Buffer.
Buffer. Okay. So what color it changes, ma?
Wine red color.
Wine red color, ma'am.
Why it is changing into wine red color?
Due to the dissolved salts.
Due to the
Dissolved
what is
salts.
forming in water? What is forming in water, ma?
Calcium
Wine red color
EBT.
Calcium
EBT
EBT.
or
Magnesium EBT.
magnesium EBT, calcium EBT or magnesium EBT. Then what you are doing?
Adding that complex to EDTA.
You are adding EDTA to that complex solution. Okay, what you are getting now?
Colorless stable complex.
Calcium EDT or
Magnesium EDTA.
Magnesium
Magnesium
EBT.
EBT.
it is a
Colorless stable
Colorless
complex.
stable complex.
stable complex. So what color you observed then?
Blue color.
Blue.
Blue
Blue
color.
color.
Blue,
So
ma'am.
wine red color changes to blue color after complete reaction of EDTA with calcium or magnesium. So this is the principle, ma. Where ma noise chesedi? Who is that? So it is known as complexometric method, because here EDTA, it is forming complex with metal ion, either calcium or magnesium. So I told you because here it is forming complexometric titrations are those reactions where a simple ion is transformed into a complex ion. So these are no need to write, but you can understand, okay, why it is called complexometric method. Okay. Okay, ma. So next class we will discuss procedure. Ma. Procedure 4 steps are there. I told you what we are taking. We will prepare the standard water. We'll take the tap water, hard water. We'll take the boiled water. Okay. So procedure we have to discuss. After that calculation part we will discuss. Ma. So that is about EDTA method. Students, you understood my principle?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Everybody,
Yes, ma'am.
what are the chemicals we are using?
EDTA.
Why it is known as complexometric method?
Because we have
Students, why it is known as complexometric method? Answer to this question. Then we can leave the class.
We are using a ligand, hexadentate ligand.
Hexadentate ligand.
Because EDTA is a ligand, it is sharing its electrons with the
Metal ion.
metal ion and forming a
Complex.
covalent bond.
Covalent bond.
Okay, forming a covalent bond, and so here we can see the complex compound formation, calcium EDTA or magnesium EDTA complex. Anybody is having any doubt, ma?
No,
You
No,
understand
ma'am.
principle?
Yes, ma'am.
Okay, Mashin. We'll leave the class now.
Okay.
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 Yes, ma'am.
What you are thinking, ma? Nikhil? Nikhil Akash?
Yeah, ma'am.
What you are thinking sitting like
Yes, I'm watching.
that? Understood class?
Yeah.
Sir, no.
Nikhil.
Understood.
Because this is the online class, no, you have to listen.
I'm
Okay,
listening.
na?
Yeah.
Hmm?
Scientist, ma'am.
All the students, you have to listen. You have to attend for the classes and you have to listen. Okay? Students, shall I leave the class? Anybody is having any doubt?
No, ma'am. Kashif.
No doubts, ma'am.